Right. Am I live? I seem to be. Okay. So, Advent of Code, number 15. Let's go. Still in the Odin programming language. Run. Yes. Okay. The newly focused parabolic reflector dish is sending all of the collected light to a point on the side of yet another mountain, the largest mountain on Lava Island. As you approach the mountain, you find that the light is being collected by the wall of a large facility embedded in the mountain side. You find a door under a large sign that says Lava Production Facility, and next to a smaller sign that says Danger, Personal Protective Equipment Required Beyond this point. As you step inside, you are immediately greeted by a somewhat panicked reindeer wearing goggles and a loose-fitting hard hat. What is a hard hat? Oh, a hard hat is just a helmet. The reindeer leads you to a shelf of goggles and hard hats. You quickly find some that fits you, and then further into the facility. At one point, you pass a button with a faint snout. Snout? What does snout mean? Oh, museau. Okay. With a snout mark and the label "Push for help." No wonder you were loaded into the trebuchet so quickly. No wonder you were loaded in the trebuchet so quickly. That was the first day. Push for help. Ah, okay. You pass through the final set of doors surrounded with even more warning signs and into what must be the room that collects all of the light from outside. As you admire the large assortment of lenses available to further focus the light, the reindeer brings you at a book titled Initialization Manual. Hello, the book cheerfully begins, apparently unaware of the concerned reindeer reading over your shoulder. This procedure will let you bring the lava production facility online, all without burning or melting anything unintended. Before you begin, please be prepared to use the holiday ASCII string helper algorithm, Appendix 1A. You turn to Appendix 1A and the reindeer leans closer with interest. The hash algorithm is a way to turn any string of characters into a single number in the range 0 to 255. To run the hash algorithm on a string, start with the current value of 0, then for each character of the string starting from the beginning, determine the ASCII code of the current character of the string, increase the current value by the ASCII code you just determined, set the current value to itself multiplied by 17, set the current value to the remainder of dividing itself by 256. After following... Actually, that kind of looks like a real-world hash algorithm. Like, I think, for example, MD5 sum and so on, they split the message into blocks of a fixed length, and then do reminders on this. Or XOR, I don't remember. I implemented MD5 sum and SHA-1 once, but it's far away. And it was too hard to understand even if I implemented it. After following this step for each character in the string, in order, the current value is the output of the hash algorithm. So to find the result of after following this step for each character of the string, the current value is the output of the hash algorithm. Okay, so to find the value on the string hash, 0, okay. So the result of running hash algorithm is 52. the initialization sequence, your puzzle input is a comma-separated list of steps to start the lava production facility. Ignore new line characters when parsing the uninitialized sequence. To verify that your hash algorithm is working, the book offers the sum of the result of running the hash algorithm on each step of the... For example... okay, the initialization sequence puzzle input, comma-separated list of steps to start the lava production facility. This initialization sequence specifies 11 individual steps. The result of running the hash algorithm on each of the steps is as follows. Rn1 becomes 30. CM... Oh, okay, that's just the stuff we have to hash. Okay. In the example, the sum of these is this. Unfortunately, the reindeer has stolen the page containing the expected verification number and is currently running around the facility with it excitedly. Run the hash algorithm on each step in the initialization sequence. What is the sum of the results? The initialization is one line. Is one long line. Be careful when copy pasting it. All right. So let's take this one as example. Xclip example. Yeah. Then run the thing. Then let's make a procedure called hash that is on string that returns an int. And again, I forgot I made Odin not in Golang. So what was let me pick the hashing algorithm again. Determine the ASCII code. Okay. Yes, but I need okay, so current is equal to 0. Then we do 4, 4 C in, and I need to convert this string to a slice of bytes. So let's do it like this. I think that would work. Okay. At the end, we return current. Then we have the ASCII value, and then we do current plus equal C. Okay. Then current value to itself multiplied by 17. Multiply by 17, and then current value to the remainder of dividing it. So modulo modulo 256 mismatch type, and that's fine. Let's just convert it back to an int. Actually, we can have this. Yeah, I think either is fine. Do I have to convert it to an int actually? Yes, I do anyway, so let's do it like this. Then we have to do for, I think it was called a command. Command in strings. Okay, I don't have auto-completion. Strings split iterator of s, and actually I need to put the address of s, and it's just a comma. And we need to do hash of command, and then we have a sum equal to 0, and then we do sum plus equal to this, and we print ln part 1 sum. Okay, this was extremely easy. Let's see. Oh, wait. And let's try to Is there... Okay, it's only one line, that's perfect. So let me run this for the input. I get this number. I forgot to mention for the example it was correct. Remove the space. Submit, right answer. Damn, that was 10 minutes. That was extremely easy, which means that part 2 will be extremely painful. Okay. You convince the reindeer to bring you the page. The page confirms that your hash algorithm is working. The book goes on to describe a series of 256 boxes numbered 1 through 255. The boxes are arranged in a line starting from the point where lights enter the facility. The boxes have holes that allow light to pass from one box to the next all the way down the line. Okay. Okay. Inside each box there are several lens slots that will keep a lens correctly positioned to focus light passing through the box. The side of each box has a panel that opens to allow you to insert or remove lenses as necessary. Alright. Along the wall running parallel to the boxes is a large library containing lenses organized by focal length, ranging from 1 through 9. The reindeer also brings you a small handheld label printer. That's the thing to label cables. Yes, okay. The book goes on to explain how to perform each step in the initialization sequence and a process it calls the Holiday ASCII String Helper Manual, Arrangement Procedure, or HashMap for short. Okay. Each step brings the sequence of letters that indicates the label of the lens on which the step operates. I cannot. Each step begins with a sequence of letters that indicates the label of the lens on which the sequence operates. The result of running the hash algorithm on the label indicates the correct box for... okay. So since the hash result is between 0 and 255, we will run this on like the command somehow and get a mapping into for each of them between 0 and 255. The label will be immediately followed by a character that indicates the operation to perform, either an equal sign or a dash. If the operation character is dash, go through the relevant box and remove the lens with a given label. If it is present in the box, then move any remaining lenses as far forward in the box as they can go without changing their order. Filling any space made by removing the indicate length, no length in that box has a given label, nothing happens. If the operation character is an equal sign, it will be followed by a number indicating the focal length of the lens that needs to go into the relevant box. Be sure to use the label marker to mark the length, the label given in the beginning of the step, so you can find it later. There are two possible situations. If there is already a length in the box, okay, let me see an example because I cannot understand this gibberish. I mean, I can understand that there is commands and labels and you have to do an action and put it into boxes. After rn1, box 0 is set to rn1. So the number is the focal length and rn is like the label. After cm minus, okay. After qp equal 3, box 1 is equal to qp3. After cm is equal to 2. After qp minus All the 256 boxes are always present. Only the box that contains any lenses are shown here. Within each box, lenses are listed from front to back. So each box can have multiple lenses. Okay. Each lens is shown as its label and focal length in square bracket. To confirm that all of the lenses are installed correctly, add up the focusing power of all of the lenses. The focusing power is a single lens is the result of multiplying together 1 plus the box number of that lens in question, the slot number. Okay, that's the reducing part. At the end of the following example, the focusing power of each lens is as follow. Okay. Okay. With the help of the following. Okay. I didn't fully understand it, but I understand that. So, example, we have a bunch of. We have a label, then an action which is either equal or minus. And if we have an equal, we have as well a number, which is the lens, the focal length. And for input, it's the same thing, but with larger labels. Okay, so let's call this part 1 sum. Oops, part 1 sum. So it's the same. Then we're gonna have, I guess, boxes, which is going to be 2.6 length array of dynamic, and then it's boom, 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 boom of lens. And so a lens is struct with label, which is a string, and focal length is an int. Okay. So we can do if command len command -1 is equal to a minus. We do something, else if else we have label, and here we can get the label by doing command, and it's actually just like so, but it is like this, I think. Yes. So that's the label, and here label, then we have an equal sign, then we have focal length string, and this is equal to strings partition of command, and the separator is an equal sign. And here we can, I don't know, we already know how to form the lens. Label declared but not used, that's fine. That is fine for now. So I didn't quite understood all this wall of text. All this wall of text. Inside each box, there are several lenses slots that will keep a lens correctly positioned to focus light passing through the box. The side of each box has a panel that opens to allow you to insert or remove lenses as necessary. Along the wall running parallel to the boxes is a large library containing lenses organized by focal length, ranging from 1 through 9. The reindeer also brings you a small handheld label printer. The book goes on to explain how to perform each step in the initialization sequence, a process it calls the holiday sum, or hashmap for short. Ah, okay, they want us to like simulate like a very small hash map. Okay. Yeah, actually, this data structure is kind of a hash map. Generally, I put a... So a hash map is generally a fixed array, or like a dynamic array, but you can do both. So you have a fixed array, and then for each slot you have a linked list. And so what you do is you hash the key and then try to put it in this array. And if you have a conflict, you push it to the linked list you have for each slot. I should do videos on data structures. That could be nice. Especially the less common ones like hashmap or dynamic arrays. Because everybody does like linked list, but like linked lists are, well, nowadays kind of useless, but I feel like since inserting into a linked list is slower than inserting into a vector. Isn't it a list of lists? Yeah, in my case, it's a list of lists, but I was talking about hashmap. I mean, actually, it could be a list of lists as well. Huh? Like for a real hash table, yeah, that's a better word for it. I mean, the way I implemented it in C was just allocate a fixed size array first, and then for each slot of that array, it's a linked list. But actually, it could also be a dynamic array for each slot. It doesn't matter as long as you can insert multiple elements in those. So yeah. Hi, by the way. So back to the world of text. Each step begins with a sequence of letters that indicates the label of lenses on which the step operates. The result of running the hash algorithm on the label indicates... Hello! The label indicates the correct box for that step. The result of running the hash on the label indicates the correct box for that step. Okay, that makes sense. So I just have to run the hash. So I do hash label, and then we know on which slot of the boxes we have to run things on. Same thing here. The label will be immediately followed by a character that indicates the operation to perform, either an equal sign or a dash. That I already have this information. If it's the operation character is a dash, go to the relevant box and remove the lenses with the given label. If it is present in the box, then move any remaining lens as far forward in the box as they can go without changing their order. Filling any space made by removing... okay, it just says remove, basically. So, if it's a minus, we remove it, and so we know that the index is this. And then we do boxes at index this, and then I think there is probably a remove at in Odin. Let me restart the LSP because this is a bit scuffed, slice, and then there is a remove. No, there is no remove. There is a built-in remove. Right, let me look at the Odin overview. Remove. Unordered remove. No, I want ordered remove. Okay. Okay, so it's just a built-in function. Okay. So it's ordered remove. Remove an element that specified index while keeping the order of the other elements. That is exactly what I want. I need a pointer. Yes, I need a pointer to this. And then the index, which I need to find. So need to find the index first. Let's create a slot which is boxes at this, and then we do slice. Is there like find or locate, or not sure how to. Let's see. Sort, byte, swap, sort, scanner. Isn't there like an index or a swap? Remove and realign the memory for the rest of the lenses so that it is acting somewhat. So like it's acting like something has removed. Remove and realign the memory for the rest of the lenses. Yeah, but I think what you mean is in the slot we just have an array of lenses, and when we remove one, we have to shift all the one on the right of it back one slot, which is, I think, the order the remove one is what it will do. I mean, I may be misinterpreting what it's saying, but yeah, well, I think the function will just do that by itself. I don't think I need to worry about that. Split, add, sort. Come on, tell me you have a thing to find. To find stuff. You must have. Into dynamic, get first. No. Equal filter. Enumerated array. Come on, buddy. Come on. Count, contains, concatenates, compare, clone. All of any. I thought I used that in like a previous day as well. Find. Max index. No, it's not what I want. Index. Max index. It's called binary search, but there is, I mean, in my case, it's not binary search, but it's linear search, I think. I don't know why I just didn't search the keyword search. That was a bit strange of me. So there is linear search proc, which allows you to return an index. Okay, that's perfect. So slides, linear search proc, we want slot, and then proc that gets length as a first argument and returns a bool, I guess. Yes, it's boolean, and we do return. Fuck, but I can't do this. Because the proc you declared inside a scope, or like the lambda proc, like the lambda functions, or like, I mean, you know what I mean, like functions inside that you declare inside of other function in Odin cannot get the variables from the scope above. So I cannot do L label is equal to label. I don't think, I mean, I'll try, but yeah, undeclared name label. So yeah, fuck it, let's just do li in in slots, and then I just do a loop and I do if L label is equal to label do, and then we do the ordered remove. Actually, let's do this like this. And we break the loop, and the index we want to remove is I, and we want to remove on slot. Okay, so that's for the removal of one. And that should be it. Huh? Example. Anything else? I don't think so. Yeah, that's fine. Let's do, if the operation character is an equal sign, it will be followed by a number indicating the focal length of the lens that needs to go in the relevant box. Make sure to use the label marker to mark the length, the lens with the label given in the beginning of the step so you can find it later. There are two possible situations. If there is already a lens in the box with the same label, replace the old lens with the new lens, remove the old lens and put the new lens in its place. Not moving any other lenses in the box. If there is not already the length of the box, add the lens to the box immediately behind any other lens. Okay, so in a case it's a replace, in another case it's an append. So I think we can do basically the same thing here. And we do again for lens. Actually, I should call this by this full name, will be slightly cleaner. In slots. And we do again if, and we have a found variable that is called false. That we will use later. And if we do lens label is equal to label, we do slot I is equal to length of label, and I need to import strconf. Don't need this one, and strconf attoy of focal length string, like so. And we need to do found is equal to true, and if it has not been found, we do append slot. Actually, let's create that above. Oops, like so, and we do inserted lens is like so. And we do inserted lens. Otherwise, we do inserted lens here. I can make that a do. Okay. And let's try to print stuff out. Println of boxes. I don't think this will look clean, but yeah, indeed. Let's do for box in boxes. If len box is greater than 0, let's print I, and continue, and then empty, println box. Actually, we need to do. I think that's fine. Oh no. For box in boxes. So that's just the slot actually. Slots. So it's the same slot we had above, and if we ignore it if its length is equal to 0. So that means that this never happens. Hello. Do we go there? We do. Do we go here? We do not. Do we... So that means that found is... it's not found. So we insert it. That is quite strange. Let's see. Slot. And the example is RN1, QP3. Yeah, so it is. What if we print the slot here? Right as we get it. It's always empty, so the happen does not work. The happen does not work. Maybe the remove is going wrongly. So what if I just never remove? Okay. And so if we print the slot at the end, there is always a label in it. But there is nothing in the box. So does that mean that this is like, I don't know, it's like the slot is a copy of the actual slot? I just looked at floor slot in boxes. Do delete slot. I need to do that at the end. That doesn't help me though. Let's remove most of the logic. Let's remove most of the logic. Wait, let's do the... So here I'm putting the boxes. Let's... Actually, I'm already doing this, but I'm going mad. So yeah, there is nothing in the boxes. What if instead of doing this, I do directly this? Okay, so that works. I did not... So I guess it makes a copy of it, but it's strange because it's a dynamic array, so it doesn't make sense to make a copy of it when I do this, I think. I would think. Maybe it creates like a local variable that points to the dynamic array, but this gives the address of the actual dynamic array. In any case, maybe I can do this. Then here I just have slot. Okay. And so I take the address instead of taking the stuff. And here I need to... Will that work? Is there like automatic dereferencing? Seems like it. Seems like it. And let's print... let's do a cleaner print where I print label and slot focal length, like so. Wait, Oh no, we need to for lens. It's called lens here. In slots, do just print lens and println at end, and I need to just a slide separator. Can I do this? Ah, yes. This label like so. And let's print this up. Okay. So looking at the example, box 0. Box 0 is rn1. And after cm minus, we just have nothing. After qp3, we have, yes, I need to maybe print this to like see these different steps. That is like this here. Oh, right, that looks about it. rn1, then rn1 qp3, then rn1 cm2 qp3, then yes, I forgot to add this, of course. And that is good. That is good as well. That is not good. That is not good. It should not be there. This should not be here. Let's make sure I have the correct command. Command is command. So that is all fine, but here qp minus, and it does not remove qp3. Do I have the correct? Yeah, it's the exact same issue. It is the exact same issue, I think. Qp minus removes the qp3. Okay. Then pc equal 4. Yep, that looks correct. AB5 looks exactly the same. PC minus exactly the same. PC this exactly the same. OT7 exactly the same. Okay, I think it's correct. Now let's comment out all the prints. Up. And let's look how to reduce all this to the answer. All of 256 boxes are always present. Only the boxes that contain any length are shown here within each word. Okay. To confirm that all of the lengths are installed correctly, add up the focusing power of all of the lenses. The focusing power of a single lens is the result of multiplying together 1 plus the box number of the lens in question, so the slot number of the lens within box 1 for the front line. 1 plus the box number of the lens in question. So at the very end, we have Rn1 box 1 times 1 first slot. So it's this times the index. Okay, and then you just add them together. Slot 1 plus the slot number of within the box 1 for the focal length. 1 plus the box number. Okay. 1 plus the box number of the element. So 1 slot number of the element within the box. Okay, d'accord. Okay. It's the index within the boxes and the index within the list of boxes. So for box, let's call it a slot, I guess. I call it a slot everywhere else. I need the index in boxes. Up, and then for lens in we again need the index in slot. And then we do part 2 sum starts at 0, and then we do part 2 sum and plus equal. I think it's a plus. Huh? Yeah, it seems like a plus. So it's I plus 1 times j plus 1, I guess. Yeah, j plus 1 times length, focal length. And let's print part 2, part 2. Okay, and this is 145. Yes, that is correct. Let's try with the actual inputs. Yep, let's copy this. Make sure that the part 1 is still correct. Yes, it is. And hopefully up. Yay! Man, this day was extremely easy. How is it possible that I spent like 3 hours and a half on the previous one, but this one is like it's like a softball. Okay, I mean it's a bit strange. I guess it's like the mid break or something. I don't know. Alright. That was nice. That was nice. And I learned a weird thing about dynamic arrays where if you put them into a variable, you get like a copy of it, not really a reference to it, which is slightly strange to me, but okay. Yeah, I guess it makes sense. I mean, it's like any other data type, I guess. When you do that to an int, you get obviously a copy of an int. Slices are the same, but yeah, I guess I just never encountered that case before. Let's remove all the dirty printing stuff. Is there any way to make it cleaner? I don't know. Seems fine to me. Seems completely fine to me. Let's make sure. Functions. What do you mean functions? I mean like other data types that. Yeah. Don't get it. Functions. I mean, I like functions too, huh? But you know, you have to add some context, I'm afraid. Let's valgrind this. The steps you are repeating. The steps I am repeating. Put in functions, the steps I'm repeating. But am I repeating stuff? Like, I'm repeating this, but... this, like the linear search, kinda, but like... I don't know, it's like 2 lines. Do I really want to make a function for 2 lines of code? That sounds like over-engineering to me. But besides that, I don't really see anything else that is repeated. Let's see. I do have one memory leak. Need to run it in debug. Need to run it in debug 54. This, which is strange because I forgot. Did I remove the delete? Also, no, I didn't. Why is it not deleted? or slot in boxes do delete slot. That is... That is quite strange. Why does it not... Why doesn't it get deleted? Oh! Forgot the defer. Alright. Let's do this. Valgrind. No memory leaks. Alright. Looks good to me. Looks good to me. Yeah. 66 lines of code. That is alright. Yeah, don't see anything else to do. Alright, I'll stop the live and hopefully tomorrow isn't like the complete opposite of this day where I'm gonna have to spend 8 hours on the problem. But yeah. Anyway, see you.